Okay, so we are looking here at one more question here, and this time we are going to find the locus of point P. Locus of point P when it moves as per given condition here, given restriction here. So this is the restriction here. It says that Z is basically your indicated by your point P x comma y in complex plane, and it moves in such a manner that these two sides are equal. So here what we're going to do is we need to again geometrically interpret both of these. Now this kind of question could be done in two ways. One is you interpret it geometrically, another one is you work through this algebraically, which means that we just replace z with x plus iota y on both the sides and then try to find a relation between x and y, and that would be the locus of point P. We will look at we'll have a geometrical approach here. So this one here, this z mod z minus I, we can see that basically it is equals to length of vector from iota to z, which basically is same as, you could say that distance of our point P from one iota is basically 0, 1. And likewise, when you say the other quantity, which is basically this, which you could write as mod c minus 1 minus iota, and that is just similar to the previous one, is equals to distance of point P from minus 1 minus iota, which basically is minus 1. And these two distances are equal, which means that your point P moves in such a manner that its distance from 0, 1 is same as its distance from minus 1 always. So if let's just draw this. That's my complex plane here, and so my point 0, 1 is this point, and other point minus 1, minus 1 is minus 1, minus 1 is this point. So now we need to ask yourself, our point P moves in such a manner that it is always at the same distance from both the points. Obviously, this point would therefore move along the perpendicular bisector of the line connecting these 2 points. So let's call it this point A and this point B. What we are looking at is the perpendicular bisector of this point, and this is our required line. So this is our locus of P. So say once we got this interpretation, now we need to use our knowledge of coordinate geometry to find the equation of this line. So first thing we need to find is the point M, which is the midpoint. So coordinates of M is equals to, I'm just writing this so that you know how to write in test and exam. So midpoint of AB, you need to write. You can also write here locus of P will be perpendicular bisector of AB. You need to say that. So you could say that's point A, point B. So midpoint, we always know how to find midpoint. The coordinates of midpoint are 0, minus 1 upon 2 and 1. Sorry. Yeah, so basically you're adding them. I hope you remember how to find the midpoint. So that gives you minus half, and this gives you 0. Now you need to find the slope of line AB. So this is slope of line is, if you remember, it is y2 minus y1 over x2 minus x1. Simple enough. Y2 minus y1, if you do it 1 plus 1 divided by 0 plus 1, which becomes 2 over 1. So this is the slope of line AB. So slope over perpendicular bisector, I'll indicate that by m. Required slope is equals to m is equals to minus 1 upon 2. If you remember, slope of perpendicular line is minus 1 upon m. So therefore, equation of locus, I hope you remember, it is y minus y1 is equals to m times x minus x1. So I'll take that as my y1. It doesn't matter which point you take. So my apologies, so what we are trying to find, we are trying to find the equation of a line which has slope equals to minus half and which passes through this point. So y minus 0 is equals to, that's m x plus half, and you rearrange it and you end up with the equation of this line as 2x plus 4y plus 1 equals to 0, and that's the locus of your point P. Okay, let's look at next question, and this again you need to use some sort of geometry there. It says point P and Q in the complex plane correspond to complex numbers Z and W respectively, and triangle OPQ is an isosceles triangle with OP equals to OQ and P and Q. So the first question is very straightforward. You just need to draw a diagram for this. So you can draw a Cartesian argand plane here, and that's my argand plane. And whenever you show an argand plane, always remember to show your real and imaginary axis. So this is your origin. It says OP, so let's say this is my OP. It doesn't matter what you take, very general. So that's your P, and OQ is at 90 degrees. So you have, that's your OQ. And it is said that this is this and that is Q. And simple enough, this is your Z and this is equals to W. That's what it is shown here. And then it says, and triangle P, angle POQ is a right angle. So that's what we have shown. You've written everything there. 1 mark, nothing much to do here. Now, next part is, it says that you need to show Z square equals to W square. Now here you need to think, there's nothing given there. You want to use a complex number. It's the chapter is basically, the topic is a complex number, and you got a complex plane here. You got complex numbers, but no complex number is given other than this information. So before you can do any kind of operation to come to this conclusion, you need to have value of Z and W. That's the starting point. And here you don't have Z and W, you don't have anything. So in such cases, what you do is you always assume, and we are going to assume here, because you cannot start your operation, you cannot start the solution unless you have Z and W. And you're not given, so they are not given. So what you do is you just assume them so that you can start. So I'll assume that, say, Z is equals to R cis theta. Now here R basically then is a length OP, and cis theta, it means, if I go back to my previous diagram here, I can see that this angle must be theta then. The angle that Z makes with the real axis is theta, so that angle is theta. Once you got this Z, you can find out the W as well. Now, so W, Again, to describe W, you need the length as well as the angle it makes with the real axis. So length of W is also R, because it's an isosceles triangle and it says that OP and OQ are equal. So length is R. So we can say here that W is equals to R. And cis, now what's the argument of this OQ? Argument is this angle. We already know that this angle, that angle with real axis, angle that P makes with the real axis theta, and this angle is 90 degree. That angle is 90. This angle is theta. So that whole angle is theta plus pi over 2. So that our W complex number becomes. Now, once you got these complex numbers, now you're on the familiar ground and you should not have any problem to solve it. So let's take a look. We have to find way to prove this. So left hand side is equals to z square plus w square. So z square is r cis theta square plus r cis theta plus pi over 2 square. That gives you r square cis theta plus r square cis 2 theta plus pi. Take r square common, it becomes, sorry, not cos, cis 2 theta plus cis 2 theta plus pi. Write that as cos 2 theta plus iota sine 2 theta cos pi plus 2 theta plus iota sine pi plus 2 theta. Now here we use two identities, which basically pi plus identities. So the identities are as cos pi plus 2 theta is equals to minus cos 2 theta, and sine pi plus 2 theta is equal to minus sine 2 theta. We have the left hand side becomes, you got r square cos 2 theta plus iota 2 sine 2 theta and minus cos 2 theta minus iota sine 2 theta. That gives you 0 as required. So in these kind of questions, you really need a starting point. And when, I mean, there's a general, there's something to note for other questions of this type as well, that whenever you don't have your starting equations or relations or anything, then you just need to assume them. Okay, we'll stop at that.